In this session, we will cover the new FDOTConnect GeoTech tools to be released in the next release, July release of the FDOTConnect workspace. So just a brief history. Traditionally, we've utilized for FDOT boring hole production, if you will, the GeoPack Borehole Navigator tool, which was part of GeoPack. In the OpenRoads Designer tools, that has not been forwarded, the Navigator tool. What they did include in the ORD 10.7 and 10.8 was a tool called OpenRoads Designer GINT Civil Tools, and that essentially imported data from a GINT database in both the native database format and the Excel version of that. For the first two FDOTConnect releases, we were supporting those tools with a sample Excel file that you could format your data in. However, in ORD 10.9, the import function for the GINT Civil Tools from a spreadsheet was removed, and as such we moved towards just replacing or building a tool through the FDOTCAD development team, and that is what we're going to cover today. Again, it replaces the SS4 GeoTech tools, SS10 for the SPT data spreadsheet, which I'll cover. It can import in a traditional or legacy Borehole, BHR, and MTL file formats. However, that has changed slightly. It plots 2D boring hole locations for plans, and it also plots 3D cylinder borings in a model for section views. The tool does not project onto a cross section. You need to reference in the 3D model to whatever models you want cross sections created from in order for them to appear on a cross section view. It also does create the reporter core borings for sheets, so the standard structural spreadsheet can be plotted to a reporter core borings, just like the old tool. The tool resides in the FDOT menu, or the tool set. You'll see there's a group of tools here. There's a GeoTech Data Manager, the Place Boreholes tool, and the Reporter Core Borings tool. In the GeoTech Data Manager, this is the tool or the dialog that allows you to import or create a new data input file for both roadway borings and structural SPT borings, or the SPT spreadsheet. As you'll see, you can actually use this form to enter data if you don't want to create either of those two input files, and then essentially it will create an XML output file. For the Borehole Navigator file format, it does, well, first of all, it imports the legacy SPT spreadsheet and also the legacy Borehole and MTL files. However, you need to combine them into a single formatted file. There are samples of both of these two files delivered in the project workset GeoTech folder. So if you create a new project, the two sample files will be in the GeoTech folder. If you have already got an existing project, you can go out to the delivered workspace and look in the zero work set template and look in the GeoTech folder, and they will be in that folder as well. This is just the sample of the SPT boring worksheet, and there you can enter this data in here into these particular areas for everything from the header to the blow counts, the stratum data, the lab test, and it will all get plotted on the report of core borings. And we'll also plot the holes into the file. This is the sample roadway, what used to be the BHR file, so you can see that both files are combined into a single spreadsheet with a separate worksheet for each, the boreholes and the materials. The actual headers or the column header names have to use these names in order for it to import properly, so we recommend that you use the sample workbook that was delivered in that GeoTech folder, or you can just look at the screenshot to see what the headers are. I will also mention that the CAD manual does have the new format. If you look in chapter 6 for the prerequisites here for GeoTech files, there is the new format and the actual file names of what those headers should be for both the material and the borehole tabs. We don't have a sample of the SPT boring in the CAD manual. This is again the headers for the material tab of this workbook, and we do recommend that you name this file the project number geotech.xls as a recommendation. Like I said, once you've either imported or opened up that file, you will see the data in this dialog, and you can add and edit the data. If you need to modify something about the input, you can see here this is a data input screen. This is the data as it was imported, but if you have additional data, lat long, that you want to add to it, or the soil descriptions that go with it, you can go to the lab test and actually edit this information right here. Well, actually not the lab test, but you can pull these pull downs for AASHTO classifications, USCS, put in the descriptions if they aren't in the format of the file itself. But you do see that there are, for the material, you can add the description here for AASHTO. There's also a column for the SCS, well, actually not in the roadway. So soil description and the AASHTO classification can be added. It doesn't have to be. Now, if you just wanted to use this tool to create data, you can just go to an Add Borehole, which is the other button, and then you can start adding the different types of data. If you want to just use this as your input screen, rather than using a spreadsheet, you can just use this tool. And it does have an area to add in the lab test data, so this is where you can put in start depth, end depths, the water content, the passing the 200 sieve, the plasticity index, liquid limits, and then so on. Any other core data that you might have from the test results, you can add this in the lab test section of the Add Edit Borehole. Once you've got all the data in the GeoTech Data Manager, you then do a file save as, and you save it to an XML file in the GeoTech folder. And that becomes your input file for the rest of the tools. Alright, so then you're ready to start placing, in this case, roadway borings. So this is the Create File tool. You can see that there's a roadway geotechnical design file for the boreholes. So this is where you're going to put in the 2D representation of where the locations are, and also the 3D representation will all be in the same file. So you just use the create file tool for that in roadway. And then go to the place borehole in plan. And you can see that what this tool looks like, and I'll swap over into the screen here and show you how that would work. So first of all, you would use the create file tool, which is over here on our menu. And if you go to GeoTech design files, here's that the auger borings RD file, and you just create the file. I'll just go ahead and open one that I've already created. Alright, for 2D then, I'll close this 3D view for now. Focus on the 2D view. Whenever you go to import these files, what's important is to reference in your alignment file. So if you'll note, which is down here, I've referenced in my alignment file and either the servrd or the terrain file in order for it to know what the surface elevation is. And then of course, once you create the 3D model, that's referenced to this normal model here as well, which I have turned off. So then this is the GeoTech Data Manager tool, and this is where I can go and import a borehole navigator file. So I've got one over here, and if I open this up before I import it, you'll see that this has two tabs here, one for the boreholes. It has the alignment name populated, the station, the offset, or if you didn't have an alignment and a station offset, you could use easting northing. You cannot plot by latitude, longitude, and this is just additional data. And then if you have, so if you're using the surface, you don't need elevation, but if you had that, you could enter that. And then there's the water elevation type, and there's columns for the groundwater encountered or 0-hour water depth, the date, 24-hour water depth, the date, and seasonal high water. And it will plot that accordingly. And then over here in the materials, again, you have the borehole ID, the stratum ID that came off of the soil survey, and then the elevation type, the depth of that material, and then this is optional whether you want to put in the classification and the description. So this is where you would open that file up, and you see that it will read it. As long as it's in that format, it reads it. You can edit these individually. So here's where you could go in and add more data if you had it. You notice that the classifications are all listed here, and then you fill in that particular field for the description if you wanted to enter them by hand. And then once you have those all tidied up, so to speak, then you just do a file save as, and you save it to this XML file. We're not giving any directions on that name yet, but just to be consistent, I would probably use the project number, call it geotech.xml or whatever matches your input file. So once you have that file, that's when you go to these tools here. So the first one is place in 2D plan. And what you would do is you would first go to the input file, choose open, tell it you want to use the surface so that it knows automatically that this is the existing surface, and then you would choose the OK button, and it would automatically go out here and plot these cores as they appear here in this screen. Now if you click on this and go to properties, you'll see that there's an item type here called Borehole, which includes a lot of the information that's in the input file, and it's also what we will eventually export to the data portal for the GIS, which is a requirement now to have all boreholes in the FDOT Enterprise Data Portal. So by using this tool, it's already ready, and now all we have to do is provide this file to the Enterprise portal, and it'll be ready for publishing as another map layer. But that's just for your information of how this tool was built. And that is the 2D portion. Next, again, I just mentioned that adds the item type data. The next would be to plot these cores in a 3D file. So I'll show you that tool. Again, I'll just open up this other view, and I'm going to close this view and just expand the 3D view. You can see the results. But essentially you do the same tool, only you choose the 3D model. And it's also important that this file has the 2D alignment file referenced to it. So you can see I have the 2D file is referenced, and because I had the terrain and I created the default 3D, it gave me the 3D alignment as well. But what's most important is to have the 2D alignment, because that has the stations for plotting it. So then you go to the place the boreholes in the model, and you're going to do the same thing. You're going to pick the borehole.xml file, choose open. It will use the existing surface to plot those. You can change the diameter if you want to, and then when you choose OK, it goes ahead and it plots these 3D cylinders with different colors for different strata, and also this disk for the water table elevation. And if you click on the disk, you can see that that's the seasonal high water that was plotted. Any of these that don't have the regular groundwater shown in another disk was groundwater not encountered. So there are some other boreholes down here that may have those. And let's see if they're in here somewhere. Most of these didn't have any groundwater encountered, so they didn't plot. If you click on this strata, you'll see that that's the strata type 2, the soil type, and the soil description that came from the input file. If I look at the blue layer, that's strata 3, and the material type light brown. So that's really it for plotting these. Now, as far as getting them to appear on cross sections, I will show you essentially what you're going to do is reference this model to any other model, and then go ahead and cut your sections. Now, how do you know if you're at an exact location of these boreholes, right? So whenever you do the drawing production name boundary tool and you choose cross section, and then you select the alignment, you do get this list here for event points. So you can tell it to include event points, and I've created an event points list called GeoTech that has the station offset of all these borings. And then whenever you create these section boundaries, you can either include event points only or have them integrated with the rest of the interval. So I'm just going to do event points only, choose this create drawing, and you see that it's automatically finding all the locations of where I've included the event points station offsets in this event points list. And if I hit the data point, you'll see that it's created those drawing boundary section planes out in this view, and then it would go ahead, and if I followed through with this, it would go ahead and create those sections or those drawing views where those locations are. Now the question is, how do you get the event points list? So the place where you do that is in the alignment file. They live with the alignment file. So if I go back to the roadway folder and open up the alignment file, and go to the geometry tab and say event points list, and then pick on this alignment, you'll see that I have entered in a few of the locations. I didn't do all of them. If I needed to add another one, and I'm not sure if this will go right to a location, but let me zoom out to one. The last one I did was 183. So let me add a 180, the 184. So I could simply start by creating a new list, and then I go in and add these by station offset, and I just snap to the center of the 2D core that's referenced to my alignment file. And this will add another entry. And now you'll see there's a 184 at a 51-foot right offset. And you just keep adding each and every one to your list. And then when you go to cut the sections, you can use that event points list, either integrated or individual for the section boundaries. So that is how the 3D models is generated. Just another note here, make sure that you reference in your 2D alignment file and that you have your active terrain set so that it knows how to plot those at the correct elevation. If for some reason, and we've seen a data set that has this, where the core hole does not fall within the limits of the terrain, it will put the boring at a 0 elevation. So just be aware of that. So what I didn't show is that the pin, or this line here that's drawn above the terrain, is for you to be able to locate it if you've got the terrain shaded. And it also includes all of the item type information, the same as what's in the 2D cell file in the 2D plan. And then if you look at the cylinders, you can see that they have the lithography item type data associated with them. And that the disc here also represent the high water. The reason it's a disc is so when you slice through it, you will see that line, and we can label the seasonal high water plotted on at that correct elevation. All right, the next step is to create the reported core borings. If you need to for roadway, the tool does work. What you would do is go to the create file tool and create this RPT BRD file, reported core borings for roadway. If you're doing this for your SPT borings, you would go to the structures discipline, other sheets, and there is a reported core boring sheet right here, this B number, and you would create the sheet for that. The tool works the same. Once you get in that sheet file, you go to the reported core borings, you browse for that same XML file. Make sure you toggle it to roadway if it's a roadway boring reported core boring sheet. And then you can change your annotation scale, your number of borings per sheet, and then the vertical exaggeration is expressed as a % of the horizontal. So 100% would be the same horizontal, the same vertical. A 10 vertical exaggeration, you change this to 1,000 in that situation, if you did want to exaggerate in the Z. So I'll just go back to here. I'm going to close out of this tool and open up the report of core borings. Now I've already plotted it in this file, and it does actually create a new model. So you can see that I had several auger borings on this project. I think there was 30, well, I don't remember, 32 or something to that effect. So it put 4 per sheet. So if I double click on one of these sheets and then fit the view, you'll see that those are the 4 that it plotted for the first sheet. Those are the next 4, and so on. And this tool again is over here under the report of core borings. If you're doing SOL for roadway, and then you browse out to the GeoTech folder, find your XML file, open it up, set these settings, few settings, whatever you need, and hit the create report, and it would go ahead and create all these drawing models. From there you can just, there is a sheet model that's created when you create the file, so then you would just reference those drawing models into the sheet model already set up. The same workflow for the SPT borings. So this doesn't have anything in it because it's in the model files. So again, this is the actual sheet model. This is the drawing model that gets plotted. This particular data set only had 2, so when I went and did the report of core borings and loaded up the other project data for the bridge, I would set it to structural. You notice the difference, but one has soil patterns, the other one has stratum numbers. You can also, there are some other options for the structural, and again the same sheet setup options here, and you just hit the create report and it plots these out here. It has all of the test data. It also shows you the blow counts. It's patterning for the different soil types. And then from there you just again add it to the sheet model. And it's just a matter of referencing in the drawing model to the sheet model. And that's how you create the report of core borings. So hopefully these tools will be useful in the FDOTConnect 10.9 workspace. And with that, I will go ahead and stop this recording.